So if you want to design a table, we are
I'm
follow.
sorry,
Yes.
but some students can join because there is a problem with code.
Okay. If you have OCS problem, you can visit our IT office. Okay.
No, he can join in a Zoom conference.
Okay.
Yes. Do you have like a password for this conference?
No, it is not.
Because it requires. He says that it requires a password in order to let.
If you want to enter to this course, you should come from the OCS system. Outside is not allowed in Formaides. Okay.
Yes, he comes from OCS, but
if you have any problem to use OCS, you should see the IT office. Okay. So if you want to design a database, and if you want to make a table inside it, you should follow 5 rules. One of them, identify the field names. Second one, identify the data types for that field, identify the index field, identify the primary key field, identify the relationship between the tables. And in the last lesson, we have mentioned much about how to set the field names and how to set the proper data types for them. Today, mostly we will mention about what is the index, what is the use of index, how can we select our index field, and then we will mention about the primary keys. And in the next coming lessons, we will mention about the relationships. Let's remind what is the field names and the data types. If you are going to make one table, as you know, there is some columns in our table. Then there is some columns. We are calling these column names. You can call these column names as a field, categories, and or attributes. They are all same things. And we have some rows. We are calling these rows or records. For example, record 1, record 2, record 3, record 3, record 4. Or we can simply call them rows. Yes. Or tables. You can call them table. In some books, you can see they have called it table. Every field, for example, this name field, as you see, it is obviously is a text field. Yes. Surname is a text field. Father name is a text field. Address is a text field. Boarding is a Boolean type, logical type. Yes. Phone number is a looks number, but it is actually text field. Yes. And if you want to use some field as a text field, you can use varchar or mvarchar, or you can use char and char type. We have explained what is the difference between these 4 types. If you have some field which you want to keep some currency inside them, you can use money type. If you are working with decimal numbers, you can use float or real data type. If you are using only whole number, you can use int type. If you are using Boolean types, logical types, yes or no field, you can use bit type. And if you are entering some date information, you can use date type. We have mentioned about them before. You should, when you are decided or choose your data type, you should choose the optimum type. What does it mean? For example, for one name field, for example, let's do here. For example, you have one name field. Name field. For example, for this name field, if you want to use n var char n var char 50, use it. but don't try to choose optimum size. For example, instead of here, you can write 100. Yes, nvarchar 100. In that case, what are going to do? You are just wasting your storage place. Yes, because most of the names, they are not longer than on the word. 99% of the names on the word, they are the shorter than 50 character length. Yes, that's why you don't need to use more than 50 actually. Try to choose best option. Yes. For example, for one laboratory you want to make, for example, computer inside the computer room you want to make one list. For example, computer number. Yes. Computer number field. Computer number field. Yes. For example, you can have another computer type, computer brand, you can have other field. But for this field, you need to use computer number is an int, yes? But there is a one better, this int can store from very large numbers. Instead of int, if you use small int type, you can use small int type. Yes, there is a small int type. It is better in the SQL Server that we have small int type, because small int type will occupy less space in the memory and in the computer storage, and it is also will increase your processing time to change or write data in the database. That's why your computer CPU will be used less if you are going to choose optimum as much as smallest data type. It is important to choose data type by the means of the computer performance. Okay?
Okay.
We mentioned all of them, this one. For example, here you are going to see one example database. For example, student int field is a int type. You can choose. Last name, nvarchar 50. First name, nvarchar 50 type. It is a type of this field. Student address, nvarchar. This one, nvarchar. Country code, nvarchar. Look at here, country code. It is telling we are country code. It is something number, yes? For example, every country and every city has a code, yes? That code actually numbers, but that code looks numbers, but we are not going to use them in the place of the numbers. We are going to use them as a text, because you never seen like that question. Your country code bigger than my country code, yes? You will not see like that question, yes? Or your country code plus my country code is equal to my friend country code. You are not using this country code for any mathematical calculation or logical operation. That's why country code looks as a number, but that number as a just symbols. Yes, we are not using as a number. But if you, for example, tell age of the student, age of the student, it is a number, because you can easily sort that numbers. For example, if you want to find out oldest or youngest student in the class, you need to make order students by the age of them. That's why age is a number data type. Birth date, it's a date type. School fee is a issue of the currency, how much you are paying to school. That's why there is a one better type, money, for it. You can use money type for it. So today we are going to mention about third one. You should know this 5-step very well. First one is defining the column names in one table. The second one, finding out the column types. Third one is identifying index. Yes. So why actually it is optional. This is optional. This is optional. This means you mustn't use it, but it is a good practice to use indexes. in every professional designed database, you can see some index field. Let's see one example, for example. For example, in this place, look at, there is a one index field. Yes, index field. Most of the student or people, they are forgetting to make index in their database design. Actually, it is very important. You should, if you are a professional design database, you must understand use of the index, and then you should, in your database design, you should set a few index in your table. It is very important because it will increase, speed up searching time, searching performance. It will speed up searching time. For example, if you are searching something in your database, you can find easily and in a short time if you are using index. Also, later, for now we are designing single tables, but later we will start to design more tables. In our database, in the most 99% of the database system, there are more than one database. Yes, there are more than one tables. If you want to link this table, we are going to use index field. If you don't have index field in your tables, you cannot make connection between the tables. That's why if you are working with, it is important, if you are working with single table, actually you don't need to use index, but to use index because of two good reasons you should use index field in your designs. One of them, to increase your performance of the search, and then to link the, if you're working more than one table, to link the tables to each other, you need the index fields. You have two good reasons to use index. So how can you select index field? How can you select index field? For example, in your database, if you have this field, if you have this field, which field is suitable to set it as an index field? You should ask this question by yourself. If you answer of this question yes, you should set this field as an index field. For example, when you finish the design of your database, in the future, in which field you will make some search. For example, if you are making one database for school management system, later, most probably, you will search the students according to their name and surname. Yes, that's why to indexing name field and surname is a good idea. Yes, or sometimes you may search students according to their school number. Yes, that's why school number. If you have in this design, there is no school number, but if you have school number column, it is a good idea to index this field. You can tell like that. If indexing is good, let's index all of them one by one, without trying to find out which field should be indexed. Yes, easily, let's index all fields. If you index all fields, what will happen? In that time, indexing has some advantages, also some disadvantages. There is a trade-off. You should index one field or you should not index. Yes, index is increasing search and accessing time, but also index is using this space and slowing down when you add, delete, or update a record in your table. That's why it has also disadvantage. You should not, that's why it is not good idea to index all of them one by one. You should, if you really need to index one field, you should index. If you want to find that field, you should ask this question by yourself. In which field I will make some search? For example, we told if you are making school management program, you will make some search according to the student name, student surname, and then maybe according to the school number, you will make some search. Yes. Also, to indexing some field will not give you any advantages. For example, we taught in the last lesson. In the last lesson, we taught if in one field, if there is some values, but that values is not changing too much. If values in one field is not varying too much, in that case, it is not good idea to index in that field. For example, let's find like that one field. For in this table, there is no like that field. Maybe school fee. Yes, school fee. If you look at the school fee field, inside it, you cannot see very different numbers because most of the students paying to school almost same price. For example, computer science department price is almost same for every student, or international relationship for department almost same to every student. Yes. For example, gender field. Gender field is a good example for this type of the example. Let's look at it. There is no gender field here, but doesn't matter. If you have gender field, gender, because one student is a male or female. When you look at that field, you will not see any other value. You will see either male or female. This is like that. For example, we are going to use index for search. Yes, for search. How we are going to use in that index? For example, think in your company there are two high building, 50 floors. Two high building A and building B. Think like that. One company. You have two buildings in your company. 50 floors here. Building A and building B. And for example, you are telling at the gate, where is the Mr. Ahmed office? Mr. Ahmed office. This is also 50 floors. 50 floors. Big two building, 50 floors. And in the gate man, you are asking to gate man in the gate. Where is the Mr. Ahmed office? He is telling in building B. He has helped you? No, because we are going to one huge building, and when you enter that building, you should search and you should find by yourself. Yes, it is helping not much. Yes, like that. You can tell they are the females, they are the males, for example. Yes, if you tell me when I search one student, if you ask the index, where is for example Ahmed, he is telling he is inside the males. We are going to this place, and it is not helping too much search. Yes, but if you are searching by the names, yes, A, B, C to Z. Yes, when you ask where is the Ahmed, when you ask that gate man, yes, porter, where is the Mr. Ahmed, he is telling inside the A building. You are just going to do, and just instead of finding all this building, you are not looking at them, just you are going to this place and you are finding Mr. Ahmed office easily. Yes, this is helping. That's why indexing name field is a good. Yes, it's a good. But indexing gender field indexing gender field is not good at all. Yes, don't index gender because it will not help. Yes, it will tell you are asking porter where is the Mr. Ahmed? He is inside the M building, and you should search by yourself again. But when in this system you are asking where is Porter? Where is Mr. Ahmed office? He is inside the A building, and you are just going to here and you are finding easily. After that, it is easy to find. Yes, that's why indexing will help you too much. If in one field, if there is some data which they are not changing too much, if almost all field, all values inside that field is the same, don't index this field. It will not just, it will slow down your adding, deleting, updating time, and it will occupy space, useless space in the disk space. That's why don't use index this field. If you have some field that contain 2 or 3 different values, for example, gender field, it is contain male or female, yes, don't index it. Or if you have one field, photo field, for example, and if it has image type, don't index it, because indexing image type will not help to find wine record. That's why just it is a waste of this space. Don't index this field. I hope you understand this important point. If you want to index one field, you should think by yourself. You should index that field or you should not index this field. And if it is helping you to find that record, it is better to index this field. So how many types of the index there are? There are 4 types of the index: unique index, non-unique index, clustered index, non-clustered index. When you want to make index, you should decide which type of index you will use. After that, you can, if you decided which type of index, you can do index. Unique index, non-unique index, you can guess from the previous lesson. For example, GSM number can be used as a unique can be used as a unique index, because every student should have different telephone number, phone number. Yes, GSM number. Email address also can be used as a unique index. If you want to index email address field, you can index that field as a unique, because everybody has specific unique email address. Everybody email address different than others, unique address. But if you want to index name field, you cannot unique. You cannot unique address. You cannot use unique address. Why? Because in one school or one class, there are many students. They can have same name. For example, in this region, Dastan is a famous name. In one class, easily you can see if more than 1, 2, 3 students, they are using same Dastan name. Yes, that's why name. If you want to index name field, you should index it is non-unique index. You should use non-unique index. But if you want to index this field, you can use unique index. Or if you want to index email address field, you can use unique address, unique field, unique index. And second type of the index, clustered index, non-clustered index. So clustered index, in the clustered index, and then data staying in the same place. If you look at this phone book analogy, for example, page D in page D, index here in the same place, and data in the same place. Yes, but in the non-clustered index is staying in the different place, data in the database staying in the different place. For example, in this book, index staying at the behind of the book, but data related to Mr. Rose staying in these pages. Data staying in these pages, but index staying at the back of the book. But here, data, for example, it is about the index is here. Information related to A in the same page. Index and data in the same place. But in the non-clustered index, index in the different can stay in the different place. Data can stay in the different place. Let's see one example for index. For example, this index. This is our actual table. For example, in our table, we have person ID, person type, first name, and last name. And then we have index by using first name and last name. We have index first by using first name and last name. And look at actual table here. But apart from this table, computer or SQL Server making one more list. Actually, this list is not visible to the users. This table is visible to, if you want to see what are there inside this table, you can see. But you cannot see in the index. But there is another table. SQL Server making another table. And in this table, according to first and last name, all names are ordered. Look at. In this place, look at, names is not ordered. King. This is the order of the entry. For example, this person entered the database first. This is the actual database. But in this list, in this is done by the index field, and then it is ordered. For example, if you are looking for Rob, yes, you should look at this first one. Rob is not there. Go to next one. Go to next one. Go to next one. You are lucky in the third, fourth record, you find Rob. But if you are looking for Rob, if there is an index according to the first and last name, you can go to the index table. It is on the R. Just go to the R. You don't need to look at the A, B, C, D. Just go to the letter R, and Rob should be inside the Rob. And then you should follow the index number. Index number is telling it is in the fourth place, and just directly going to the fourth place, and you are finding Rob easily by using index table. This is an index table. This is an actual table. Yes. This is an example for non-clustered index. Why? Because actual data staying in one table, index staying in another table. In this clustered index, let's see one example for clustered index. Primary key is an example for clustered index. Primary key is an example for clustered index. This means index ID field, this field is a clustered index. Yes, it is a clustered index. This means, for example, when you enter the first time, you are entering Tommy. Second time, you are entering Samir. Third time, you are entering Samir in this order. Fourth time, you are entering Ahmed. Lastly, you are entering Fatima. But when you look at the employee list in your table, you are going to see Samir at the first place. Why? Because we told ID will be cluster index. Computer will order data in the database according to the ID field. Samir entered to database secondly, but it will appear when you want to look at the table. When you look at inside the table, you'll see Samir in the first place. Fatima, for example, entered to table lastly, but it is appearing in the second because its ID number second. That's why it is in the table appearing in the second place. Computer will rearrange. You can enter these employees to your table. This employee will be reordered inside the table when you enter. When you enter a new record, it will be reordered according to the ID field. And then if you look at this is the actual database, and this is the in clustered index ID. It is in the same place. ID, clustered index, and then actual data staying in the same place. I hope you understand unique index, non-unique index, clustered index, and non-clustered index. So in one table, maximum, this is important, maximum you can have only one clustered index. You cannot have 2, 3 more clustered index, but you can have many unique index, or you can have many non-unique index, and you can have many non-clustered index. So let's learn how to make index now. How to make index. So if you want to make index, you are going to use this command, this syntax. First of all, this is a standard word. Always you must write create. After that, you should tell type of the index. We told our index can be unique index or non-unique index, clustered index or non-clustered index. But there is no keyword for non-unique. Yes, if you want to make this is important. If you want to make non-unique index, you are not writing here anything. If you omit all these ones, automatically by default, SQL Server will make non-unique index. Yes. But if you want to make unique index, implicitly you can tell you want to make unique index, or you want to make clustered index, or you want to make non-clustered index. For example, here, create unique non-clustered index. You are telling make unique non-clustered index. Secondly, we are using index keyword. Also, this is a standard like create word. You should always write create. You should always write index. For example, create. You can omit this place. If you omit all this place, what will happen? It is a, if you omit this place, it is a by default, this index by default is a non-unique and by default non-clustered. It is a non-unique and non-clustered default. If you not tell anything, about the type of the index, it will be non-unique index and non-clustered index. And then after index word, you should give one name for your index. You can give one name for index. For example, here, IX index for last name. You can give like that logical names. This means we want to make one index for the last name column. After that, this keyword also standard on. After that, you should tell in which table you want to make index, table name. For example, in the table student, I want to make index. After that, inside the parentheses, you are telling in which field you want to make index. In which field you want to make index. For example, I want to make index in the last name field. In the last name field, I want to make index in the last name field on the table students. It's my index name will be index for last name, and my index type will be by default non-unique, non-clustered. And ascending index. This means if you are making index here in this example, for example, when you make index table, list index according to the ascending order from A to Z. If you write descending, Z, make the index table Z to A. Usually they are using ascending. There is no difference between ascending and descending, but usually we are going to use ascending. If you want to make descending, you can use this keyword. In this index, what is happening? We are using standard create keyword. After that, we didn't tell type of the index. It is a by default non-unique and non-clustered index. And after that, I am going to give one name for my index. You can tell index one on table. In which table I want to make index, table student. In which field I want to do on the state field. Yes. Here you can tell create unique index. Yes. And this index will be unique index. And then its name is a index one. Of course, if you are making in the same place index, you should give different name. If you, for example, use already index one, now you can use index two. If you are making in the same place, but if you are making in the different tables, you don't need to use unique names for index. On the table student, school number is ascending. Yes, school number can be good candidate for unique index because every student, it's a good option. Every student has different school number. That's why it is a good idea to set as a unique index. Yes. So employee, inside employee no field is in this example index by using unique and clustered index. Here in this example, employee no field index by using non-clustered and unique index. Yes. Employee name is a unique index. Yes, that's why you can use unique index. It is because every employee has a different number. So if when you use primary key and unique keywords, you are making actually index. Let's see, for example, if you want to make this table and you set student ID int will be primary key. If it is like that, this student ID field will be index. And since it is primary, it will be clustered index. And it will be unique. If you look at here, you can see easily. If you set this, you must memorize this rule. If you set one field as a primary key, this field automatically will be. You don't need to create index for this field separately. Explicitly later you don't need to make index for this field. This field automatically will be indexed implicitly will be index. But which type of index it will be? If you primary keyword will make automatically unique and clustered index. And if also unique keyword, if you use one for one field unique keyword, it will make automatically unique non-clustered index. Unique and non-clustered index. Unique keyword will make unique and non-clustered index. Also, we told in one table you cannot make more than one clustered index. If there is a primary key already, clustered index is done. You cannot make another clustered index in this table. Yes. Don't forget these two keywords, primary key and unique index. By using primary key and unique, you can make easily index field. Which type of index? If you are using primary key, you can make unique and clustered index. And if you are using unique keyword, you can make unique non-clustered index. So let's do this table in our database. If I want to connect to the local SQL server, and then inside the college database, let's run new query. Let's look at inside the college. There is a table students. There is already table students there. That's why I am deleting this table first. Now there is no table students. This table also. Now when I execute these ones, and table student is done. Let's refresh and check. As table student this one, it is done. When you open it, when you go to indexes, you can see 1, 2, 3, 4, 5, 6, 7 index is done in this table. Let's see what are they in this table. First of all, we told primary key will make unique and clustered index. Yes, this one. This is a primary key, clustered index. Yes, this is a clustered index, and it also unique index. This is a primary key. This is our index done by using this word. Second one is a second index, unique index. Unique index, this one, unique index. Unique and non-clustered. Unique and non-clustered. If you look at what is the name of this index, PK table student some blah 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 words. UQ table student blah blah some. These names given by the SQL Server, because I didn't tell here what will be my index name. I just told the computer make one primary key, automatically it does. I didn't specify name. But here, if you look at index, name will be index 1. Yes, it will index 1. You can find easily. Look at this index. You create this command make or implement this index, because I have told already make unique index, but name it, call it ix1, index 1, index 1. Yes. Also, it is a unique. Yes, unique index is correct. If you not tell clustered or non-clustered, it will be by default non-clustered. Also, there is something here you can understand. This is a clustered or non-clustered index. Clustered index in one table can be one time. Yes, primary key already make one cluster index. Yes, that's why you cannot make any more cluster index. That's why this index 1 should be also non-clustered, because it cannot be clustered. Clustered index made already done by primary keywords. Yes, and second index is I told second index here, second index, but actually this is the first index done automatically. This is the second index done. The second index, this is the third index, but we call it index 2. It is a index 2 on the table, first name. Yes, index 2, this one. If you look at here, we didn't tell which type of index we want to make. Yes, after create, you should tell which type of the index you should do. Yes, after create word, you should tell which type of the index you should do. You should either make unique, clustered, or non-clustered. If you not tell anything by default, it will be non-clustered, non-unique, and it is correct. Non-unique, non-clustered. Yes, this is the index done for last name field, and same, non-unique, non-clustered. If you look at birth date, index 5, this index done on birth date field. This means later, if you make some search, if you search some students according to their birth dates. For example, think now for now this table is empty, but think later, for example, there is a 1 million records in this table. If you are making search according to the birth date, you will find in a few microsecond or millisecond, you will search. But if you are not if you didn't make this index field on your table, if you make some search, a few seconds, maybe you will wait in front of your computer to find your students according to the birth name. By the same way, if you search one student by the school number, you can find it faster than before, because this field indexed. Yes, unique index. I hope you understand how to make index. If you are making design table, first things you should set the column name, student ID, school number, first name, last name, student address. Second things, you should define or you should specify, identify their types. Third ones, you should make some index. Yes, third one, you should make some index. And also there is here one utility command. For now, you don't know what is the stored procedure. What is the one stored procedure? SP, stored procedure. For now, don't worry. What is it? You don't need to know. You don't need to know how to use this one. But this is a diagnostic command. If you want to get much information about your indexes in your table, just memorize it. Execute this system stored procedure health index, and object name is a table student. This means in the table student, it is telling give me information. We can tell, give me information about the indexes in the table student. If you execute this command, it will give you much more information about them. Like this one, you can get information. For example, index 1 is a non-clustered unique located on primary. Primary means actually when you are working with simple database, your data is staying in this place. But if you are working with, for example, telecom companies databases, can stay in the several hard disk drive, in the different hard disk drive. That's why in the partition you can divide your data into the partition. It is an advanced topic, but it is telling all data staying inside the same hard disk partition. It is saying all data staying, all index data staying in the same partition. It's telling. And then index key, which index key? School number. Yes, it was school number. Index 1 done for school number field, for this field. Yes, it is telling you. Index 2 is done for first name field. This means if you want to search one student according to his or her first name, his or her name, you can find that student fastly, quickly. Yes. For example, student ID is a clustered, unique, and primary key. Yes, primary key. And student ID field is it is a primary key. Because of primary key, we told automatically will be clustered index and unique index. Clustered and unique index, yes. School number field is a unique key. It's already, we told, make it uniquely. We told already, if you use unique key automatically will do non-clustered, yes, non-clustered and unique field. It will make unique non-clustered index. You can get much information by using this command about your indexing. If you want to get short information, you can look at under the table, you can see indexes and you can open and you can see all your indexes that are listed. So if you want to make primary key, you can use this option. What is the difference between making primary key like that or making like that? If you look at here, if you make primary key like that, you cannot name your primary key. Look at primary key names. Look at PK. This name given by computer automatically. This name going, but this index one given by you. Yes. If you are using this option to make primary key, it looks a little bit confusing and hard, but it is better. In this place, you are telling how you are doing. You are coming end of the table, and you are telling constraint. Constraint here, you can tell constraint a rule to limit a behavior or something. To limit a behavior or something. It is a rule to limit behavior of something. What is actually there are more different constraints. One of them is a primary key constraint. What is the limitation here? We can tell if it is telling if you set student ID field as a primary key constraint is telling us you cannot repeat any value for this one. Yet it should be unique. Yes, it should be unique. Just keep in your mind, if you want to make primary key field, you have two options like that. First of all, this is easiest option. Option one is just write to next to student ID primary key. Just write primary key. Or at the end of the table, next to student ID, don't write anything. And just at the end of the table, just constraint PK1 primary key student ID. And this means set the student ID field as a primary key and name it PK1. Let's do this design. Copy. Or let's change here, this place. And now I should delete this table because I cannot make same table 2 times. Delete. It will not able to delete because it has some connection. Now let's do again. I'm doing same table again inside the college. Inside the college, I am doing same table again. And then I am making some index. And I want to get information about that index. Look at now, student ID is a primary key field, but its name is a PK1. Yes, PK1. Now it has a good name because this name is given by us. You can give any name here, PK1. Now, instead of computer giving randomly some names to it, it is named PK1. Yes, it is. I told you this method looks easy to make primary key, but this method is better, maybe a little bit confusing to make primary key, but always use this method or if you want to make primary key field, because in that case you know the name of the primary key. Later, if you want to delete or if you want to change primary key field, you should know its name. If you don't know, you cannot change or delete its name. Yes, that's why it's better to know its name. In other case, you should go and you should search what was the primary key name, something like that. So here, just to know, okay, nobody doing these things, but you should know this one. For example, look at student ID field. It's a not primary. Yes, not primary. And look at school number. Here's unique clustered index. It is a unique clustered index. Unique and clustered index. This means all identity here automatically given. Okay, number. For example, if you tell identity will be automatically. For example, Tommy number will be 1 because because it is entered to system. It is entered to system. It is entered to system first time. That's why Tommy automatically will. I will explain it later. Or Tommy automatically will get number 1 as a student ID. Samir secondly entered to system. That's why it will have second ID number. Yes, Samira thirdly entered the system. That's why Samira has a third number 3. Yes. Now, but be careful, student ID is not primary key. That's why index and data will be clustered according to school number, because we told school number should index, unique, and clustered. We are telling make the school number field as a unique and clustered index. This means when I enter the Tommy, Samir, Samira, Ahmed, Fatima, when I look at the table, I will see table is rearranged according to the school number, because school number is a clustered index. Yes, school number is here, clustered index. Computer will order my data according to school number. Smallest school number is a 111. That's why Samira will come to the first of the table. It is entered actually in the second order to the table, but it came in the physical database place. It located in the first place because my index here. Yes, in this table, clustered index here. recall analogy of the phone book. Yes, on the phone book, index on the right side staying. Yes, my index is here. According to my index, other data will locate. Yes, for example, somewhere in the located first place. My index in this place, it will locate. But this design is not good design. School ID, if you have school ID, it should be primary key and should be indexed according to this place. Yes, it should not be clustered. Yes, good design of this table is this is just example to understand what is the clustered index and unique clustered index. This should be primary key and school number can be unique, not clustered index. Yes, when you set this one primary key, it will be clustered index and record will be ordered according to the student ID, not school number. But school number can be unique index only, not clustered. But yes, this is just an example to understand what's happening. So this is also not case. This is not also not case. Nobody will design like that table. But if you have one table without any cluster index, if look at int field, ID is an int field. There is no primary key here. Name, salary, gender. None of them has index. Yes. When you insert some table data inside it, what will happen? We are calling this type of table heap table, unordered structured, and unordered structured table heap table. It has special name, unordered heap table, which means when you put something, there is a heap. When you put, it is staying there. It's not going any place according to the index. When you put anything, it is staying there. When you put at the top, it's staying there. It is a like heap. It doesn't have any order according to the n index because this. In this table, there is no any single primary key, unique key, and index field. There is no any index. That's why we are calling this type of table heap table. But it is not the case. It is just experimental purpose done. Yes. Nobody will design like that table because it is very bad design. It doesn't have any primary key field. It doesn't have any index field inside it. But if you want to see, there is a for small table, for small database, it doesn't nothing wrong with this one. Yes, for single and small table doesn't wrong anything. But if we are working, we told if you are working with more than one table, you must use index. Yes, and if you want to increase your database performance, also you must use index. But if you are using single and very small size tables, nothing wrong with it. But it's not good at all design. So last 4 things. What is the use of the primary key field? What is the use of the primary key field? Why we are going to use primary key field? Yes, why we are going to use primary key field? And what is the primary key field? And then how can you find primary key? Yes. So primary key, if you are using primary key, using primary key also it is optional. Yes, it is optional. You mustn't use always primary key, but because of several reasons, it's a good practice to set one field as a primary key field. Yes. Also, we thought primary key field is actually index. It is not different standalone concept. Actually, primary key is a unique and clustered index. Yes. Primary key. If you have one primary key in your table, this means actually you have you have unique and clustered index. This means you have unique and clustered index. So what is the reasons which we are going to use primary key? First of all, it will ensure that each record table is unique. Yes. It is a unique reference. You can tell it a unique reference for every record. Unique reference. Yes. If you know this reference you can find directly. Yes, directly. For example, if we told if you are looking for somebody, for example, Mr. Ahmed, if you look at the gender reference, it can direct you according to the male's place and female's place. Yes, but if you are using name reference, it can direct you at most according to the starting letters A, B, C till Z. Yes, it can, for example, if you are looking Mr. Ahmed office, it can tell go to the letter A's office or building place, or go to the letter C place. Yes, it can reference you that. But if you have, for example, room number, yes, room number, for example, it can tell, for example, where is the Mr. Office. If you are looking reference of to Mr. Ahmed according to room number, porter he can tell to you go to the office 210, go to the office 210. Yes, but it is still not unique because in the 210 office there can be many employee. It can be 1 employee, 2 employee, 3 employee. If it's 3 employee, when you come to that door, you should ask which one is Mr. Ahmed. Yes, if there can be 3, still not unique reference. Yes, but if I will tell, for example, school number, employee number, employee number. Yes, for example, employee number is a unique. If you want to find one employee according to the employee number, if I know the employee number, I can go direct to that number. I can find exactly that number. That's why primary key is a unique reference. Yes, I hope you understand what is it. It will ensure every record in your table will be unique. Yes, it should be unique. So it will help to enforce various type of integrity. We will mention it later after relationship. In the last lesson, I have mentioned about a little bit. For example, for now we are working with single table, but later we will work with many table. If you are working with many table, you have parent table and child table. For example, in the parent table, you can have one student. In the child table, you can have exam score of that student. Yes, it is. I have explained it in the last lesson. I will not explain again, but later, when we are mentioning about relationship, I will explain it later again. And to make relationship between the table, again, it is not today's topic. Later, we will mention how to make relationship in that place. If you want to make relationship between the tables, you need primary key. Actually, you need class index field. Yes, primary key also a kinds of index field. Also, this means you need primary key field. That's because of this many good reasons. You should use primary key in your table. So if one does set one field as a primary key, it should have 3 rules. This any value, any data inside that field should not repeat. It should be unique. Yes, and any value or any data in that field should not be missing. Yes, you must have that piece of information about that record. And if you set one field as a unique as a primary key field, that field should not change, or it can change rarely. If you must to change, you can change, but it should be one. You should choose one field should change rarely inside it. Let's see these things. For example, let's look at the last name. Can we use the last name field as a primary key field? No, because our rules is clear. No repeat. Yes, name field values or data inside this field can easily repeat. Name, last name can repeat. First name can repeat. Student address can repeat. City can repeat. Country can repeat. Country code. Birth date can even repeat because there are many students, they have the same birth date. Yes, school fee easily repeat. Yes, there is no any field here we can set as a primary key. That's why we make one like that artificial student ID and int, and you can use this field as a primary. You can write here is a we will use this field as a primary key. You can set this field as a primary key. For example, if you have here school number, for example, or email address. Think you have one more email address. Email and or varchar for example 100 varchar 100 email field. Can you set as a primary key? Yes, it is fitting to rule 1, no repeat. Yes, every student should have unique email address. It is fitting first rule, but it is not fitting the second rule. It should not be empty because in one school, every student may not have email address, especially in the primary school. Yes, in the primary school, student can, or third rule also is not matching. Yes, third rule is telling no change. Somebody easily can change their email address. Yes, that's why it is not good to make to use email field as a primary key field, but school number. School number field. School number field, for example, int. If you set here, int. School number. If you add school number field, can you set as a primary key field? Yes, you can set as a primary key field because every student has a unique school number. Second one, none of the student can change this school number, and also we told unique, no repeat and no change. Another one is it was no empty. Everybody has, if one student is going to school, he or she must have one school number because that school number automatically given by the school administration. Yes, because school number can be used. School number is a good candidate to use as a primary key. School number is a natural field. Yes, school number is a natural field. But if you want as a practice, for example, if you are making one table about student, directly you can tell student ID int primary key, and you can set this field as a artificial primary key field. Yes. We explained how to make primary key before. If you set here primary key, for example, when you execute this SQL script code, it will make one key field, its name given by the computer. Yes, it's like that nonsense randomly chosen one name given by the computer. If you don't want this nonsense name given to your primary key, you can use constraint command. Constraint command will make primary key on student ID field, but will use this name. Yes, when you look at what is the name of the key, if you look at it, you'll see table student PK. This name going to give your primary key. Yes, primary key using this name. That's why we told this is a one and easy method to make primary key on your table design, but it is better to use this method. It is better to use this method. There is compound key primary key. What does it mean, compound primary key? For example, if you can tell last name, first name, and together birth name will be unique. Yes, you can compound. This means last name, first name, and birthday will be together unique. It can be like, yes. For example, you cannot find one student. You cannot find in one classroom. Every student has different name in one school or different last name. Together, it will be a little bit hard. At the same time, same name and same surname, but still you can find some student in one school has same first name and same family, but you cannot find almost any student same surname, family name, same name, and same birthday in one school. It is hard. That's why you can combination of these three fields can be set as a primary key. It is a natural primary key. It is a natural primary key. This option is a good. If you find, for example, if you look at your table, last name cannot be used primary key, first name cannot be used, student address cannot be used, city cannot be used, country cannot be used, school fee cannot be used as a primary key, and then you don't want to use artificial key field like that. In that case, you can make combination of some field here, but this combination should be unique. There should be not repeating same surname at the same time, same last name and same birthday should not repeat at the same time. You can make combination of this one. But this option is a very good option, very good solution, but it has one disadvantage. What is the disadvantage? If you look at this primary key, last name, first name, and birth date field, last name and first name is a text field. Birth date field is a date field. If you index this one, you can make index according to one, nothing wrong. But this index will work slower than number index. That's why instead of this one, it's a good solution. Instead of this one, it's better to use like that one artificial key field, because primary key field very important in the performance, because student ID this is an integer type. To search by numbers is a faster than to search by text. That's why this primary key field is a better choice. Yes, because since it is artificial, there is nothing meaningful to this ID numbers, but it is better to use this field because its performance is better than this performance. But this is also a good choice sometimes if you cannot find, and if you want to use, if you don't want to use artificial key field. So another method to make key field, for example, you have already done your table like that. You finish design of your table and you forget to set one of the field as a key field. Later, you can tell this command. What is telling? Alter means change. Change my table student, this table. I want to change this table. And how I want to change? I want to add one constraint table student PK, primary key student. This means add the student ID primary key to this table. Yes. For example, you did your table design already finished, and you forget, you look at your table, you forget to make table. Instead of deleting your table and making new, you can write this code. This code is telling change, alter my table student and add this primary key to my table. Sometimes you want to delete your primary key. If you want to delete your primary key, we are going to use drop command. Drop constraint name. Yes, that's why if you want to know, for example, now you know name of this field. Yes, table PK. Now, if you want to delete this key, you should tell drop constraint name of the constraint. You should write here table student PK. That's why if you want to delete, for example, primary key, it is better. If you don't know primary key name, you cannot delete. Yes, that's why to use this option always good to make primary key. But in this option, you are making one primary key and also you know its name. But in this option, you are making one primary key, you don't know its name. Yes, but you have one key, primary key, yes, but you don't know its name. Its name is, you should discover first this long name, after that you can delete it. Sometimes you can disable and enable your primary key. Drop a table. Drop a table, same, if you want to delete a table, you are writing, if you want to make table, you are writing here, create table. If you want to delete your table, you are telling drop table. So one more thing, not null option. Sometimes we are going to use this option, not null, not null, not null. Actually, here you don't need to use not null because primary key already is telling what was the primary key properties primary key. If something is primary key, it should be unique. Yes, it should be unique. It should be not empty, and it should not change. Yes, not empty. That's why it must be not empty. That's why you don't need to tell this one here. But if you want, you can tell. To make sure, you can tell. What does it mean not null here? First name, not null. Last name, not null. For example, if you have this table, and then if you want to fill this table through this form, for example, when you press enter in this form, these records will go into this table. But when you, in this form, when you press enter, it will not enter this information to the table. Why? Because you left this field empty. Last name, yes, it is required. When last name, because you told in the design of the database, last name is required, not null. You cannot leave this place empty. Not, it is required. This means required. This means when you enter this data, it will give you error message. You should provide an information or data for this field. Yes, you cannot enter. Not null means you cannot leave when you are filling these data records, database records, you should not leave or missing this part. So identity column. Sometimes we have seen identity. Let's see. Look at here, identity. Identity. We told student ID field with the identity field. Identity field means auto incremented key. This means you are not providing. For example, if you want to insert this data, this data to database, you don't need to provide ID number because ID number will be given automatically starting from 1. When you enter the Tommy and 301, its ID number will be given automatically. It's staying in the first place. That's why it will get the automatically number 1. When you enter the Samir ID number by given automatically by the computer 2, automatically given number. If you have artificial.
Sorry, teacher, time is up.
Yes, finishing. Time, okay. I am about to finish. Identity, this is the seat number, this is the increment number. Seat 1, increment 1. All this information is the extra information. You are not responsible because you don't know how to use these ones. You don't know how to use functions in databases. But if you want to get some extra information to be more professional, you can read this slide by yourself and you can use them in your database designs. In this slide, you are going to see some summarization, what we have mentioned about them up to now. This is a good summary. You can look at that. Okay. So do you have any question? Let's check charts.